Hi, I'm UMMU. I will explain the introduction. Gas chromatography or GC is an analytical technique used to separate and analyze volatile compound in a mixture. In gas chromatography, separation occurs using two phases, which are the mobile phase and the stationary phase. The mobile phase is an inert carrier gas such as helium or nitrogen, while the stationary phase is located inside the column. When the sample is injected into the injection port, it is vaporized and carried to the column by the carrier gas. Each component in the mixture moves through the column at a different speed depending on its boiling point and its interaction with the stationary phase. As a result, the components are separated and detected at different retention time. The retention time is used for qualitative analysis, while the peak area of peak height is used for quantitative analysis. Gas chromatography is commonly used with detectors such as the flame ionization detector and the thermal conductivity detector. Now, let's move on to the objective. First, to determine the retention time of N-butanol and 2-propanol. Second, to identify the component present in a standard mixture based on their retention time. Third, to identify the component present in an unknown sample. Lastly, to study the effect of temperature on retention time and resolution in gas chromatography. The apparatus used in this experiment include a syringe, a beaker, and a dropper. The syringe is used to inject the sample into the gas chromatograph, while the beaker and dropper are used for handling and transferring the chemical sample. The chemical used in this experiment are 2-propanol, N-butanol, a standard mixture of 2-propanol and N-butanol in a 1:1 ratio, and an unknown sample. These chemicals are analyzed to compare the retention time and to identify the component present in the unknown sample.
This is the method for gas chromatography. First, the syringe was rinsed before it was filled with the sample. The volume may be more than the required volume. We make sure that there are no air bubbles in the syringe. The air bubbles were removed by tapping the syringe gently. The syringe was held vertically, needle up, and the plunger was pushed to the required volume at eye level. The initial and final open temperature of GC instrument was set at 70 degrees Celsius. The injection and detector temperature was set at 180 degrees Celsius. Retention time of each component was determined individually. Each component present was identified by comparing the retention time of each component. The initial and final column temperature was then changed to 100 degrees Celsius to see the effect of reducing temperature on retention time and resolution of component. To see the effect of increasing temperature on retention time and resolution of component, the initial and final open temperature was then set at 140 degrees Celsius. This is the method for gas chromatography. First, the syringe was rinsed before it was filled with the sample. The volume may be more than the required volume. We make sure that there are no air bubbles in the syringe. The air bubbles were removed by tapping the syringe gently. The syringe was held vertically, needle up, and the plunger was pushed to the required volume at eye level. The initial and final open temperature of GC instrument was set at 70 degrees Celsius. The injection and detector temperature was set at 180 degrees Celsius. Retention time of each component was determined individually. Each component present was identified by comparing the retention time of each component. The initial and final column temperature was then changed to 100 degrees Celsius to see the effect of reducing temperature on retention time and resolution of component. To see the effect of increasing temperature on retention time and resolution of component, the initial...
So here are our result, which is the first one at the left. You can see the printed result that we gain from the GC machine. Then the table is for our data sheet that show that the temperature for each compound is 70 degrees Celsius, and the compound that we use is standard mixture, 2-propanol, N-butanol, and the unknown. So first standard mixture, the retention time is 1.649 and 2.044. For the second propanol is 1.633, and the N-butanol is 2.014, and the unknown sample is the 1.621 and 0.013. The next standard mixture is 1.502 and 1.646, and the last standard mixture retention time is 1.406 and 1.459, and the unknown number that we gain is 1:2. So here are the question that for our presentation, which is state the types of compounds which are suitable for analysis using GC. So towards the derivation, they also need to be thermally stable at the operating temperatures for the GC. These compounds are usually organic in nature, although certain inorganic cases can also be analyzed using specific detector such as the thermal conductivity detector, which is TCD. So the second question is why FID is a suitable detector for this analysis. So the flame ionization detector, which is FID, is suitable for this analysis because it is highly sensitive to organic compounds. Even at the very low concentrations, it is capable of detecting compounds at nanogram levels, and the operating over a wide concentration range. In addition, FID shows a strong response to alcohol such as 2-propanol and N-butanol. It's making more reliable general purpose detector for hydrocarbons and oxygen containing compounds. So the last question is the third question, which is list 2 factors which can increase the efficiency of GC column. So the first factor is optimizing the temperature programming, and the second factor is using a longer or a narrow column.
In conclusion, gas chromatography was successfully used for identification of unknown compound by comparing its retention time with standard compound. The unknown sample shows retention time that is similar to 2-propanol and N-butanol, indicating that it was a mixture of both compounds. By increasing the column temperature, the retention time will decrease and reduce peak resolution due to faster elution. This experiment shows the effectiveness of gas chromatography for compound identification and the effects of column temperature on separation efficiency.